Okay. So today we're talking about the mean of a frequency distribution. We're going to need some data first, so we're going to make up some data today. Okay, so make a little grid on your paper that is 3 by 5. We're going to make up some data. So let's say that you have 200 people in Lewiston that we ask. Anybody willing to make up a whole bunch of data for me? You doing it?
Sure.
Okay. You didn't raise your hand, but you did this a lot. So I feel like you were saying you could do it, but I wasn't quite sure. All right. So we're gonna, and I want you to be as realistic as you can about this. Okay. This is how many dogs people in Lewiston own. Our options here are 0, 1, 2, 3, and 4. I realize that that is not all the dogs that you could possibly have. You could have, of course, like 15, but let's assume that these 200 people have somewhere between 0 and 4 dogs. All right, so this is going to be my frequency. Tell me, Noah, out of 200 people in Lewiston, how many do you think would have 0 dogs?
About 100, go like 93.
93. Might want to grab your calculator and type in 93 because we need these to add up to 100.
For one dog, probably like 34. For 2 dogs, 57.
Where are you at now?
184.
16 dogs to play with.
I know.
16 people, not dogs.
Probably like 11 have 3. And then the rest into 4.
So 5?
Yeah.
Okay, I'm going to quick do a summation here. Let's just check Noah's math. 93, oops, 93 and 34, and 57 and 11 and 5, sure enough, 200, nice job. So on this one, I want to write down that my sample size is 200. Remember, N means sample size. Remember, my sample size are the people I'm asking. This is just the people I'm asking about this, not how many dogs they have. Now, how would I find the average amount of dogs in Lewiston? Per family. First of all, what do your instincts tell you? Look at the data. Tell me a stupid answer for how many dogs based on this data per family on average. What's a dumb answer? Noah?
You divide like the frequency by 5.
Okay, so like you're thinking that we would take this divided by 5 or these divided by 5?
Yeah.
Okay, that's a good idea. I definitely think frequency, this is definitely a weight. Do you guys agree with that this is a weighted mean? Because do you think that like the people who have 4 dogs should count the same as the people who have 0 dogs? Are they the same? No, one category has 93 people in it and one has 5 in it. Now, what would this list look like if I was actually to write out 200 numbers? I'm not going to do it, but what if I did? If I wrote out 200 numbers, what would the first 93 numbers be? Yeah, so I'd have 93 zeros. Can you imagine it? 93 zeros written, and then I would have 34 ones, and then 57 twos. Can you imagine the list in front of you right now? And then if we were going to take an average, we'd add all of those up and divide by 200. Do you guys understand? but I don't want to list them all out. So instead, let's call this X and this F, and we'll make this X times F. So if I had 93 zeros, that would be a summation of 0, could be 93 times 0. Stay with me, Carlos, you can do it. And then the next one would be 34 ones. What would those add up to? 34, or 1 times 34. 57 twos. 114. 11 threes. 33, and 5 fours. 20. So if I was adding up all of those dogs in front of me, I would have to add up this column. So it'd be 34 plus 114 plus 33 plus 20. 201. Did you guys get 201? 34 plus 114 plus 33 plus 20. You guys get 201? Okay. So now I'm going to take 201, which is all of the dogs added up, and I'm going to divide by 200. This is how many data points I have, which means that if I take 201 divided by 200 in my calculator, I get 1.005. 1.005 what?
Dogs per household.
Dogs per household. Does that kind of match this data? I mean, think about how many zeros there are, right? That cancel out the larger dog families. A little bit more than 1 dog per household in Lewiston, on average. Because you got some families that have like 4 dogs at their house. All right. Does this make sense to you? The only thing that we have to fix here, though, is this. What if, instead, we're going to make another graph, another table. It's going to be the same size, 3 by 5. Carlos, you want a piece of gum? You? Okay. This time we're talking about cats. And we all know that there's some crazy cat ladies out there. And I know that's sexist, but let's be honest, mostly old ladies. Some old men, sure. But ladies for sure. I mean, I'm on my way. I've got 1. I can easily see myself having 5, definitely. Especially if like a whole litter of kittens came in my life, I'd be like, well, they're all mine now. Like, I don't have a choice. Okay, so instead of what I did before, this time I'm going to say how many families have 0 to 1 cats, how many families have 2 to 3 cats, how many families have 4 to 5 cats, 6 to 7 cats, and 8 to 9 cats. This is like if I was making a frequency distribution like we used to do, remember? When you would take the highest minus the lowest and make classes. All right. This time I'm going to say we only asked 50 people in Lewiston. Who's up for making up the data this time? Who wants to make up crazy cat lady data? Noah already did his job, and it has to be one of you 4. Who wants to make crazy cat lady data? Go for it, Autumn. 50 people total. How many families have between 0 and 1 cats?
6.
Wow, we got a lot of cat families in Lewiston. I like it.
12.
Nice. Look, so many people in Lewiston have so many cats. I love this so much. Keep going.